Sorry for being late. I am audible.
Yes, sir, you are audible.
Hello.
Yes, sir.
Hello.
হ্যাঁ স্যার শুনতে পাচ্ছি স্যার।
Okay. Okay. Just a minute. Okay, I am coming to the fluid kinematics. Fluid kinematics. Okay. So in this previous lesson, we will discuss about the fluid statics, where the fluid is at rest. Now we come into the fluid kinematics, and in this case, the velocity and acceleration of fluid particles are function of space and time both. So velocity and acceleration both are the function of the coordinate x, y, z, and t. So both. So velocity and acceleration, these are the two major quantities which is depend on the space and time. These are the two things. So it is the branch of science which deals with the geometry of motion of fluid without any reference to the forces causing in the motions. So kinematics means we are deal with the change of geometry without the given force acting on the systems. So this is the fluid kinematics. So in the engineering mechanics, we deal with the kinematics in the dynamics part. So in the kinematics is the this one branch of the engineering mechanics where the change of geometry you can consider without any application of force. Similarly, in case of fluid kinematics, we will discuss about the change of velocity, acceleration, and the geometry, and we deal with the geometry of the fluid particles without any force. So this is the fluid kinematics, and this method to study this kinematics. The method to study this kinematics is two. There are two methods. One is Lagrangian method, and then is Eulerian method. So one method is Lagrangian. There are two methods. One is Lagrangian. Lagrangian method or particles method. In case of Lagrangian method, the individual particle of fluid are observed. So in the Lagrangian method, individual particle, each and every individual particle you have to observe with respect to its flowing path or streamline. So individual of the fluid are observed. And another method, that is Eulerian method. Eulerian method or point method. So here we consider, we define a pace in a fluid system, and we have to study on that region. So here we can observe each and every fluid particles, and in Eulerian method you just consider or define any piece, so any position, and we can observe what will happen at that position of this fluid particles. So this is the main difference between Lagrangian method and Eulerian method. And Eulerian method is famous than the Lagrangian method because in a fluid, if you consider this is a pipe, this is the pipe, and fluid is flowing through this line, and there are let number of fluid particles. There are number of fluid particles is flowing through this pipe. And in case of Lagrangian, you have to study all 1, 2, 3, 4, all fluid particles. But in case of Eulerian method, you just identify the space, this position of this pipe, and you just study on that region. On that region, what will happen? So 1, 2, 3, 4, every particle is coming through this space, and you have to study what will be the properties difference of 1, 2, 3, 4 all fluid particles at this position. So this is the Eulerian method, and Eulerian method is one of the most important method in case of fluid kinematics than the Lagrangian method. So based on some fluid flow, we have to classify the fluid some categories. First one is steady flow and unsteady flow. So types of flow. Types of flow. What is types of flow? So in the types of flow, there will be some, we have to classify this flow some different point of view. So flow is defined as a continuous deformation action is the fluid is known as flow. So continuous deformation when acting on a fluid element, and this is known as flow. So in the case of flow, first we classify this flow in two categories. One is steady flow, another is unsteady flow. So first is steady flow and another is unsteady flow. So in case of steady flow, what will happen? So in case of steady flow, the fluid properties. Keep in mind the fluid properties like density, like velocity, like acceleration is remain unchanged with respect to the time. So in case of flow field, the fluid properties are unchanged. So it is the flow in which the properties such as velocity, acceleration, etc. do not change with respect to the time at any point in the flow field. So if we consider a flow field like this, so this is the region. Okay, in this region, you just see there are the fluid particles. There is another fluid particles. Another fluid. So if you observe this flow, then you set a reference that there is no change of fluid properties. There is no change of fluid properties at at any point with respect to the time. It will be the remain same throughout the flowing condition. So this is the steady flow. What will be the unsteady flow? When the fluid properties change, like velocity, acceleration, etc., with respect to time at any point. If you just consider this is your region, you consider this is your region, and there is no change of fluid properties with respect to time at any point, then this is steady flow. So steady flow means there is no change of fluid properties like such as velocity, acceleration, your density. Okay, all no change of fluid property with respect to time at any point is known as steady flow. So what will happen? du by, let u is the velocity, so dv by dt. So there is no change of velocity, so velocity is constant, so it derivative will be 0. Similarly, d of rho dt will be 0. So this is the steady flow. What is unsteady flow? In case of unsteady flow, what will happen? So there is change of fluid property. So change of with respect to time at any point of this region is known as unsteady flow. So this is given you that d like dv dt not equal to 0. Similarly, d rho dt not equal to 0. So acceleration with respect to time is not equal to 0. Now the second classification is uniform flow and non-uniform flow. The second classification is uniform and non-uniform. This, the second classification is uniform flow and non-uniform. In case of uniform and non-uniform, what will happen? Just it is like as your steady unsteady, but here with respect to time, a flow term as uniform if there is no change of direction and magnitude of velocity with respect to pace at any given instant of time. So generally, instead of property, it will define by the change of velocity. Okay, instead of fluid properties, it is with respect to pace, and it is generally the properties may be changed, property may be changed with respect to the time. The property of the fluid may be changed with respect to the time, but the property may be changed, but it is defined by the velocity with change of velocity with respect to time. If there is a change of velocity with respect to time, then with respect to pace, then it is called non-uniform flow. If there is no change of velocity with respect to pace, then this is called known as uniform flow. Uniform flow means the velocity is constant throughout the pace. So each and every section, if there is long tube and the velocity here, velocity in this point and velocity in this point are same, then this is called as uniform flow. But when the velocity will be changed with point to point and it may vary point to point, then this is called non-uniform flow. So in general, it is defined by the change of velocity. But what will happen if there is a change of pressure? Actually, the pressure, acceleration, or all other properties like density may be changed, but it is defined by the change of velocity, in terms of change of velocity. So now, if I write this thing, so we can write in this way that a flow, there is no change. So uniform flow means there is no change of velocity in direction and magnitude. Okay, no change of velocity in the direction and magnitude. This is called no change of velocity in the direction and magnitude. It's called uniform flow. That's if there is change. So non-uniform flow, the velocity change. So this is the non-uniform and this is the uniform. So velocity change with respect to pace at any given instant. So no change of velocity in direction and the magnitude with respect to pace at any given instant. So mathematically we define the uniform flow as like this, that du dx or du ds better is equal to 0, but here du ds not equal to 0. So this is the main thing. So what will be the steady and uniform flow? So if you combine these two, then what is steady and uniform flow? Steady and uniform. What is the meaning of steady uniform flow? Steady and uniform, both. There are these two properties are remain present in the fluid motion in a fluid. So what is this? Steady and uniform. Anyone?
So velocity is not changing with respect to both time and space.
Good. So there is no change of velocity with respect to actually fluid properties. In case we just have the uniform term is coming, so there is no change of velocity. Actually, uniform property is defined by the velocity. That's why we can tell that there is no change of velocity with respect to pace and time. So just consider a pipe like that. This is the pipe. You just identify 3 points. Point A, point B and point C. Now at t equal to 0, and this we concentrate on the pipe at t equal to, let t1. Now t equal to t1, here t equal to t0. So net here the velocity is 5 meter per second. Here also 5 meter per second. Here also 5 meter per second. So three different pace, but for a particular time, but three different pace, you get 5 meter per second, 5 meter per second, 5 meter per second. So this is defined as the pace is difference, but time is constant. Now if time is changed, now the same pace, the same place, here 5 meter per second at point A, at point B also 5 meter per second, at point C also 5 meter per second. So there is no change with respect to time. So this at t equal to t1 you get the same velocity, and t equal to t0, and the pace at point A, at point B, and point B is remain. At each and every pace, the velocity will be same. So this is the steady and uniform. Now coming to the another point, that is determine in another classification based on the direction. So 1D flow, 2D flow, 3D flow. So generally the velocity V is defined as Ui plus Vj plus Wk. So you are familiar with this thing from your, so any vector we can generally has three components, like along x-axis, along y-axis, along z-axis, like u, v, and w. So here we see u is the velocity along x-axis, v is the velocity along y-axis, and w is the velocity along z-axis. What will happen if v equal to w equal to 0? Then the velocity is only in x direction. Similarly, let the case 1, this is for 1. Case 2, let w equal to 0, then v equal to uy, so capital V, this is capital V, this is small. So capital V, this is capital V, okay? So this is capital V. So v equal to uy plus vj. So this is uy plus vj. So here we get two-dimensional vector. Similarly, if there is no zero term, then we get three-dimensional. So that's mean when 3D, what is the 3D flow? 3D flow means v is the function of simply x, y, z. This is x direction function, y direction function, z direction function. 2D flow is, so this is 3D. 2D flow is v is the function of either xy or function of yz or function of xz. What is 1D? So 1D flow is v is the function of maybe x, maybe function of y, or maybe function of z. Any one component, either u, v, and w is present. If two are 0, there will be the one component present. Then this is the 1D. Now, give an example of 1D, 2D, and 3D flow. No, 1D flow. First 3D flow. Just consider x, y, z direction. If a flow like this, it can move like this. Just consider it can move like this. vortex. So if it move like this, then you can say that its circular is present on the xy xy plane and the height on the z direction. Or oh sorry, according to my diagram, the circle, the base in xz plane, and this is the height, that this is the z plane. So this is 3D example of 3D. Similarly, what is the example of 2D flow? Just consider a flow, a pipe like this. Okay, a pipe like this. So here we get this is coming, and now it will move. It will move, or you can erase this portion also, no problem. So here we see the flow is coming, then it will split into component like this, in this way and in this way. So if you consider, if this is the vector, then it has two components. Obviously it has two components. If it is flowing in a plane, in just in your floor, just a liquid line is flowing in your floor, then it has two components. So this is 2D plane. Now, when a flow passing through a syringe-like thing, just injection syringe. So the thickness and height of this flow is very small, very small. So we can consider the velocity is just completely unidirectional, and this is the 1D flow. So this is the example of 3D flow. This is the example of 3D flow. This is the example of 2D flow. And when a nurse or doctor use the syringe, then there is the no. Actually, this is the unidirectional, the one direction flow. So there is no breadth and height of this fluid flow. So this is 1D flow. So a vortex flow is the example of 3D. Any flowing condition on your floor is the example of 2D, and the syringe-like very small narrow angular gap is the example of 1D flow. So this is the classification of flow according to their direction. Now coming to the another flow. So another type of flow is turbulent and laminar. Turbulent flow and laminar. Turbulent and laminar. So turbulent and laminar. What is turbulent flow and laminar flow? So turbulent flow and laminar flow are classified according to the pattern of the streamline. When the streamline is mixed with each other, then this is the turbulent flow. And scientist Reynolds gives a parameter which is known as Reynolds number. So Reynolds number depends on some properties of the fluid and flow characteristic of the fluid. And Reynolds number is defined by, so first I sketch a diagram of turbulent flow and laminar flow. So if this is the pipe, then the fluid flowing like this, zigzag pattern. So this is the turbulent flow. It will mix with each other. And but in case of laminar flow, the fluid, there is the layer by layer flow. There is no mixing of fluid. So parallel line are there. There is no chance of mixing of the fluid. So this is the laminar flow, and this is the turbulent flow. Okay, and Reynolds actually give a parameter, and it will Reynolds number, and Reynolds number is defined by rho dP by mu, where rho is the density of the fluid, d is the hydraulic depth or hydraulic radius, of this uh, fluid or conduit, and v is the average velocity of the fluid, and mu is the viscosity of the fluid. When Reynolds number in between 5000 RE to 2000 for pipe flow, this is the range, and another range is 2000 RE 4000 for open channel. So when the fluid Reynolds number less than 500, this is known as turbulent flow inside the pipe. When it goes beyond and in between 5000 to 2000, it is transient flow, and when it goes beyond the 2000, then it is called turbulent flow. So 5000, within the 5000 and 2000, it is called transient flow. Similarly, in case of the open channel, when the fluid flow with Reynolds number 2000, it is called laminar flow. In between 2000 to 4000, it is called transient flow. Transient means the change of phase from laminar to turbulent. And within 4000, above the 4000 or beyond the 4000, it is known as your turbulent flow in a open channel. Now another classification of the flow is laminar, rotational and irrotational. So rotational and irrotational. Rotational flow and irrotational flow. In case of rotational or irrotational, what will happen? The rotational flow is the flow in which the fluid particles rotate about their mass center while traveling with the flow. So it is rotate with their mass centers. Okay, and this is called rotational flow. And irrotational flow, there is no rotation. So a flow is known as irrotational if the fluid particles do not rotate about their mass center while traveling with the motion of the flow. So there is a rotation of the fluid particles, then this is called rotational flow. I am not writing anything on this. And when there is no rotation with respect to their mass center, it is called irrotational. Now another classification is incompressible and compressible flow. Compressible and incompressible. Compressible flow, incompressible flow. So compressible, incompressible, already we discussed about this thing in terms of bulk modulus, that when the density of the fluid is constant throughout the operation, or any due to the any pressure acting on this fluid element, then this is called incompressible fluid. And compressible fluid, when the volume or density will change with the application of the force on the fluid element, is known as compressible fluid. So there is no change of density. So in case of incompressible, no change of density of fluid, and compressible, change of density of fluid. So it's depend on the change of density, and we can classify the fluid in two categories: compressible and incompressible. Another, okay, up to this. The next class I will discuss about the conservation of law of mass in case of fluid particles. So before that, you have to just go through this type of properties, fluid properties, which is related to the flow. So in the next class, I will discuss about the streamline and strict line and the conservation law of mass in case of fluid flow. Okay, thank you.